Okay guys, what's up and welcome back to my YouTube channel. Today we're going to be looking at Viet's results. Viet is this guy who found out the relationship between roots and coefficients. So he's the guy who determined the relationship between roots and coefficients. Okay, so now let's more so look at where this is applicable. You can get roots in any form of polynomial. So maybe a quadratic, a linear, a cubic, a quartic, whatever, you're going to get roots. So let's start from the basic building blocks. Let's take the quadratic. Okay, so when you take this quadratic, right, what is the general form of this quadratic? Well, you know the general form is ax squared plus bx plus c is equal to 0. Now, what many students tend to forget is that this a, they typically write x squared plus bx plus c because that's your most usual monic expression. But remember, expressions can be non-monic too, and most of the times they are. So have that a in there because it's going to help out heaps. Then you're going to let, for this, right, let the roots slash zeros, they're both the same thing by the way, be alpha and beta. Now why? That you should always be asking yourself these questions. Now, if you let, what this is saying is that if you insert alpha as x, you're going to end up getting a 0. Same with beta. That is what the roots or the zeros of a quadratic or like of an expression mean. When you put it in, so f of alpha is equal to 0. That's what this root means. Okay. Now, you can factorize this. You can factorize it to find the root. Now, how can you factorize it? Well, there are many methods. Factorize. So you can, one method of finding the roots is through factorization. Looks like I made a spelling mistake. No, not really. Your second method is through using the formula. And your third method is through completing the square. In this video, we're going to be looking at how factorize and the quadratic formula relate to finding the relationship between the roots and the coefficients, not completing the square because it's not often used and therefore we're not going to use it. Now, let's look at factorization first. Factorization. Now, when you look at factorization, you are going to have x minus alpha and x minus beta for your initial expression of ax squared plus bx plus c. Okay, so this is what you're going to have. And this is only true for monics because in a monic, right, the a is a 1, remember? And this tends to be a 1 and that doesn't change anything. But suppose this was a 2, not a 1, but a 2 or any other integer. Then, no matter how you factorize this or expand it, you're never going to get that 2 in this expression. That is why this expression is partially incorrect. Okay? So, what we're going to be doing is we're going to be dividing both sides by a. So, let's go and do that. Let's divide both sides by a. So, a, x minus alpha, x minus beta is equal to x squared plus b on ax plus c squared. C array. Okay, so now that we have this expression, look at it. Now, looking at it is not alone. Because you have a on this side, when you divide by a, this a gets cancelled out too. So, what you want to do now is you want to expand these two. So, x squared minus, you want to use the FOIL method actually. So, x squared minus beta x here minus alpha x plus alpha beta is equal to x squared plus b on a x plus c on a. Now, what can you recall from this? Well, this is just x squared minus, this is beta x, this is alpha x. So you can factorize, you can combine this, you can take the x out, and minus alpha plus beta x plus alpha beta is equal to x squared minus plus, actually, sorry, b over a plus c over a. Okay, simple. This is what we want. Now, what you see is this quadratic expression in a different form. What is this form? Well, it's x squared minus the sum of the roots, because remember the initial roots were alpha and beta, plus x plus the product of the roots. Now make a note of this because you don't find this in lots of textbooks, but this is how you can write the quadratic expression given, or once you've figured out the roots and the coefficients, the relationship between the roots and the coefficients. So now all this is telling you is that look at this part, right? Let me use my highlighter. This minus b on x is similar to this. How can I change the color? Yeah, this plus b is similar to that. That is all you need to get out from this example. So you know that minus alpha plus beta is equal to this one, b over a. Take this minus to the other side and you get the also famous alpha plus beta is equal to minus beta over minus b over a. So this is how we are able to find the sum of products. This is how you're able to find the sum of products. Now, how about this one? What is it? Product of products. Product of things, yeah. Let's draw a line here. And let's go on this side. Here, we are saying that alpha beta, the green, we are looking at the green ones now. So we're telling that alpha beta is equal to c on a because they both are similar. They're in a similar spot. So alpha plus beta is equal to c on a. And it's as simple as that. There's nothing else to talk about. This is the product of roots. So these two are your basic fundamental building blocks. So you must commit them to memory. What are you committing to memory? You're committing that alpha plus beta on a quadratic equation is always just minus b on a. And you're committing to memory that alpha beta is equal to c on a. This is when these are all roots. And you want to find the relationship between the coefficients. Okay? Simple. Now, this method, I would call it a more so black magic method actually, because if you look at it, where do you get the alpha and beta from? Sorry guys, I need water. But that's a common question that everyone asks. Where do you get the alpha and beta from? So let me show you a more concrete definition. I'm going to use dotted lines for this, but it'll make sense why I do so. Okay. So now let's go ahead and expand this. We know that alpha is equal to minus b minus root b squared minus 4ac over 2a. Because one of your root is always figured out by the quadratic formula. Then the other root is basically lying at the plus. So minus b plus root b squared minus 4ac over 2a. You know this from your quadratic formula, right? Which is minus b plus minus root b squared minus 4ac over 2a, right? Simple. So what we can do is we know our alpha and we know our beta. That's our alpha, that's our beta. So if you were to add alpha plus beta, you're essentially adding both these up. So alpha plus beta, you're essentially adding minus b plus root b squared minus 4ac over 2a to this. So try doing this, right? Minus b minus root b squared minus 4ac plus minus b plus b squared minus 4ac, all thing over, well, it's 2a. So what do you see here? What can you cancel out? That's all you're looking at, really. Well, there's a minus b and there's a minus b, so that's minus 2b immediately. Write it up here, something. And then this is a minus, this is a plus, cancels out, and then it's minus 2a. So all you're left with here, all you're left with is minus 2b over 2a. This, well, the ones just get cancelled out, is equal to minus b on a. This is a more so concrete proof and definition of how alpha plus beta is really equal to minus b on a. Okay, got it? TK. Now let's look at the proof for alpha beta, why it's equal to c on a. Well, take alpha and beta, they're your same integers. I'm just gonna borrow them here actually. Let's go ahead and copy and paste. So alpha plus beta resize. Sorry for this inconvenience, guys. Okay, sorry for that long awkward pause, but minus b minus b squared over 2a times this. Well, you can just join these brackets at this stage, add that multiplication sign, and put a bracket around. Because what this now tells us is that there's two different signs. Oh, that's so big. Okay. Plus, minus. That's what you want to be. That's what you want to notice as soon as you see. So this looks like a minus b, a plus b. So you can use the difference of two squares. Yes, you're right. So minus b, what's minus b squared? That's just b squared, and then this one, root b squared minus 4ac. Well, root b squared, if you take the squared of root b squared, you're just going to find out minus b squared minus 4ac over, well, of course, it's going to be 4a. Now, what you want to do is you want to simplify. Sorry, I'm actually wrong. It's not just 4a. 2 into 2 is 4a squared. Get it? Okay. Now, what you want to do is simplify. There's a 4, there's a 4. You want to cancel it out. But, slow it down. It's a plus here. So, when you go ahead and actually cancel it down, take the 4 out. Take the a and a out. There's one more a here. Then, take the b squared minus b squared. Well, that's just 0. So, all you're left with, really, is just c on a. Alpha beta. So, alpha beta is equal to c on a. So this is most of the concrete proof of, how half of Vietnamese results for quadratics. But let's look into more fun versions or applications of this in real life. So, you know how we did this for quadratics, right? Now we can try the same for cubics. And after cubics, we're going to try out a practice question actually. So, okay, this has been going on for some while now, but let's try cubics. So, let's take the general cubic, which is ax cubed plus bx squared plus cx plus d is equal to 0. That is the general cubic. Now that is, congruent, or that is similar to, put the alpha in the front because it's an harmonic. Well, x minus alpha, x minus beta, and here because there can be 3 roots, x minus gamma. You're introducing a new thing called gamma. Gamma looks like this. So this is how we do it. Now gamma is quite hard to actually remember, but I just write it as a L, and delta is more so like this. But we'll get into it when we look at the quartic and quintic blah blah. For now, this is sufficient enough. So what do you do from here? Well, let's divide both sides by a because we wanted to make it monic, so it's easier for us. So a, that's just x cubed plus b over a x squared plus c over a x plus d over a is congruent. What did I write? 4 lines. Is congruent to the x that cancels out. X minus alpha, x minus beta, and x minus gamma. Okay? Simple guys. This is all you're doing now. Now, leave the left hand side as it is. Now, if you expand the right hand side, what I want you to do is I want you to use a FOIL method and expand it one by one. This will take time, but go slow because you don't want to mess it up on your first time. X into x, well, that's x squared. X minus beta, that's minus beta x. Alpha thing, that's minus alpha x, and minus alpha minus beta, well, that's plus alpha beta. Now take this entire thing and multiply it by x minus alpha, and what you'll find is that you're going to end up getting something like this: x squared minus alpha x squared minus beta x squared minus gamma x squared plus alpha beta x plus beta gamma x plus gamma alpha x minus alpha beta gamma. Now that was a long line of working out. Hopefully you did pause the video and you did get these in this order, because once it's in this order you can actually just group and do things that way, because that's a group and that's a group, as you can see very clearly, because all of them have an x squared here and all of them here have the exact same coefficients, so you can take them all out. So if you write it, this will become x cubed, sorry, this is an x cubed actually, and this cancels out, well, with this x cubed that you write, x cubed plus b on a x squared plus c on a x plus d on a. Well, this x cube and this x cube just cancels out. Now you have this. This is just magical beauty. It's magical beauty, folks. So brace yourself. Minus alpha. Here what you can see, what can you see is common? Well, there's alpha, beta, gamma, but there's this x that's common in all of them. So the most logical thing to do would be to take out the minus and the x. So take out the minus and then take out the x. So alpha plus gamma plus beta, and then take out the x squared. Simple. Now add this with this. What's common here? It's the x again. So take it out. That's equal to, there's no negatives to take out, alpha beta plus beta gamma plus gamma alpha. And you're taking out the x. Simple. Now, and then you're finally just bringing this down, which is minus alpha beta gamma. This is all you're doing. Okay? Because from here, you can see that, you know, this green bit that you highlighted here is plus b on x. This orange bit that you highlighted here is c on a of x. And this is just d on a. Okay? That is as simple as it needs to get. Okay? Now, if you're wondering why it's positive b, well, if there's a negative here, take it to the other side. If there's negative here, take it to the other side. So it becomes minus b of a, and this becomes minus d of a. Okay? Simple. Now, let's look at what happens to the sums, products, and pairs. Because when you talk about cubics, we're not only talking about the sums and the products, but we're talking about the sum of the pairs. So, first let's do sums. So let me write down everything. Sums of pairs and product. Okay? Simple. So when you're writing the sum, we want to write that to alpha plus beta plus gamma. Okay? Alpha plus beta plus gamma. And then when you're writing the sum of the pairs, you want to write alpha beta plus alpha gamma plus beta gamma. Okay? That's the pairs, sum of the pairs. And then if you want to write the product, well, as you guessed it, alpha beta gamma. That's all you're writing, guys. Now, the tricky part comes under how you elaborate this. Because this alpha plus beta plus gamma, you know, is a sum, is equal to, well, if you guessed it right enough, you can see the alpha plus beta plus gamma, that's equal to minus b on a. Okay, now similarly, the sum of pairs, you can see it here, is equal to c on a. Good job, guys. You're getting the hang of it now. Is equal to c on a. And then finally, look at this one, minus alpha, beta, gamma. So this is the product, right? The product is similar to this, plus d on a. But this minus goes on the other side here, so it's a minus VE. So write that down. Product, well, that's just equal to minus d on a. Okay, simple. TK got it? That's all you're essentially doing, guys. Breathe in, breathe out. Because now, believe it or not, you're going to be touching some questions, boys. Okay. These ones might be a little challenging, so brace yourself and let's get into it. So the first question, what it's asking is, sorry, let's actually get, let's get text. Nah, the text is not going to be effective actually, guys. So, practice question. If alpha, beta, and gamma are the roots, if they are the roots of the equation, 2x cubed plus 2x squared plus 3x plus 4 is equal to 0, well then find the value of, in that case, find the value of alpha plus beta plus gamma. As you guessed it, it's alpha beta plus beta gamma plus alpha gamma. And then finally, alpha beta gamma. So they're basically asking for the sum of pairs, and products. Right, okay. So we know that the sum is minus b on a. So what's minus b? Well, that's minus 2 on 2, which is minus 1. Simple. This is all you need to be doing when you're actually doing the questions. Alpha beta plus beta gamma plus alpha gamma. Well, all you're doing is you're taking C on A. Remember that? Remember that from the previous example that we did, C on A. So what's C on A? C on A is 3 over 2. So you take 3 on 2. Simple. That's as easy as it gets, boys. Now, again, alpha beta gamma. What is it? 4 on 2. 4 on 2 because it's D on A. Because it's D on A, it's 4 on 2, so it's 2. Simple. Guys, that's all you need to do. And you got, guess what? All the right answers. Okay? That was your practice question. Now, we're going to be looking at some identities, because identities is where so it gets fun. Like, fun. Okay? So let's look at identity number 1. Identity number 1 is alpha squared plus beta squared. So when they give you this, what do you do? Well, what you're supposed to do is you're supposed to go like alpha plus beta whole squared is equal to, well, it's alpha plus beta whole squared is equal to alpha plus beta and alpha plus beta, because that's alpha plus beta whole squared, right? Then you multiply it out. Alpha, so alpha squared plus alpha beta plus alpha beta plus beta squared. So it's alpha squared plus beta squared plus 2 alpha beta, right? Now this is equal to alpha plus beta whole squared, right? Got it? Yes. Now, do you see the link, what I mean? This minus 2 alpha beta, if you switch it to the other side, alpha plus beta whole squared minus 2 alpha beta is equal to alpha squared plus beta squared. Well, bam, boom. There you go. You got this part, which is alpha squared plus beta squared. You got it on one side, and then you got what it is on the other side. This is all you need to do. You need to think, manipulate the equation, and then get what you want. Because in this one, look how it's alpha plus beta and alpha beta. You only need to sub in the two terms that you already know, because these are the only two terms that you can find out. If it's alpha cubed minus beta cubed, you need to do something else. But this you already know. Alpha plus beta. What's alpha plus beta? Yes, it should ring in your head now, guys. It's minus b on a. And what is alpha beta? Well, alpha beta is c on a. So just substitute those in, square it, times it by -2, subtract, and you'll get your answer. Okay? Now let's look at more identities, because these identities are really important. These are what screwed me over. Well, let's go into identity number 2. Identity number 2 is alpha minus beta. Okay, so this is kind of a hard one. So let's look into it. Similarly, even for this alpha minus beta one, we are going to be expanding it. So alpha minus beta, let it equal to the cube, is equal to alpha minus beta, alpha minus beta. Okay, alpha minus beta, alpha minus beta. Now, if you expand this, well, that's just alpha squared. Use the FOIL, okay, guys? Go like that. Alpha squared minus beta alpha minus beta alpha, and then plus beta squared. So it's alpha squared minus 2 alpha beta plus beta squared. Okay, that is what alpha minus beta whole square does. Now, they didn't ask us for any of this, did they? No. They wanted what is alpha minus beta. So, in other words, they want to know what is alpha minus beta. So, what we can do is manipulate it. See this alpha squared plus beta squared minus 2 alpha beta. I wrote this here, right? In the exact, these both are the exact same, except I've rearranged it so it looks kind of different. And when you write it in this form, your brain starts to think it's like alpha squared plus beta squared. Wait, I remember it somewhere. Yes, you do, because that is the identity number 1. That is what you just figured out here. So what did you figure out here? Well, you figured out that alpha plus beta is nothing but alpha plus beta whole squared minus 2 alpha beta minus 2 alpha beta. This 2 alpha beta is from this one, and this 2 alpha beta is from here. So this just becomes alpha plus beta whole squared minus 2 is just minus 4 alpha beta. Okay, that is what this alpha minus beta whole squared is. Now they only wanted to know what's alpha minus beta, so let's square root both sides. Alpha minus beta is equal to square root, okay, it's not, the line is not straight, okay, is equal to square root of x plus alpha whole squared minus 4 alpha beta. Okay, that is x minus b. Now take a break and let's look at question number 3. Let me write the question number 3. Sorry, not question, identity number 3. X squared minus b squared. Okay, look at this question and think how you can solve it. Okay, I just needed to drink a bit of water, but you want to manipulate this question again. Okay, wait, can you guys see in the right orientation? You know what, I actually don't want to risk it. We'll go back. No, alpha squared plus beta squared, well, this luckily just happens to so be alpha difference of 2 squares. So that's alpha minus beta, alpha plus beta. This makes life a lot easier because we not only know what alpha minus beta is from here, we also know what alpha plus beta is. So, no, my bad, we actually don't know what alpha plus beta is. So let's write it. Alpha plus beta into, we know that this is just, what is it? Alpha plus beta whole squared minus 4 alpha beta. We know that this is the guy. Now, yeah, sure, you want to be expanding it, but what did the question ask? The question asked what's alpha squared minus beta squared. This is luckily in the exact form that you would need it to be. So that is the entire answer done. Now, question number 4, or identity number 4, perhaps you can say. We're only going to be looking at 8 identities today, so we're almost halfway through. Don't worry, guys. Identity number 4 is alpha cubed plus beta cubed. And don't worry, we will be looking at the minus shortly. But first, let's look at the plus. Alpha cubed plus beta cubed. Well, all alpha cubed plus beta cubed is telling is that you can write it as alpha plus beta whole cubed. Okay? Alpha plus beta whole cubed. And this is equal to nothing but alpha plus beta. Let me actually shrink it up here. Yeah, this is just alpha plus beta, alpha plus beta, and again alpha plus beta. And when you expand this, you're going to end up getting this. You're going to end up getting alpha cubed plus beta cubed plus 3 alpha squared beta plus 3 alpha beta squared. Okay? That's all you are getting. Promise. Now, what can you do with this alpha plus beta squared? Well, that's a question, so you know something's happening. All you know that's happening is that alpha plus beta cubed, you're going to take these two to the other side. So minus 3 alpha squared beta. But this 3 alpha squared beta, you can write it nicely by writing alpha beta and writing it as, well, just alpha plus beta minus. So minus 3 alpha beta, alpha plus beta, and that is, my man, what the identity stands for. Alpha plus beta whole cube is equal to alpha plus beta whole cubed plus this plus that plus that. Okay, you take this stays here, right? So alpha cubed plus beta cubed. And that is your identity. That is the right answer. Okay, gotcha. Now let's move on to the next one. You know what, guys, actually, I'm going to stop there for today. So, for question 5, 6, and 7, I'll write it down here, but I really want you guys to try this on your own first. Alpha cubed minus beta cubed. Question 6 is 1 over alpha minus 1 plus 1 over beta minus 1, and question 7 is 1 over alpha squared plus 1 over beta squared, and lucky last, question 8 is 1 over alpha squared minus 1 over beta squared. Okay, these questions won't take that long. Take a screenshot of this and go try it out and let me know in the comments, and I'll make a secondary follow-up video. Thank you guys. See you in the next video.